Okay, everyone, let us begin today's session. So, welcome to week 2 of programming in modern C++. So, in this week, we learned about, wait, some people are joining. So, in this week, we learned about the const keyword, volatile keyword, and inline keyword. And then we learned about references, and then default parameters and function overloading. Okay, and we also learned about operator overloading and dynamic memory management. So the const keyword, it simply means that the value is a constant and it cannot change. Okay, so for example, you can see that const int n equal to 10 means that n is defined as a constant variable. It means that once it has been defined, the value of n cannot change anywhere in the program. Okay. Wait a minute. So if we write some statement like this, okay, n equal to 5, then it is a compilation error. And it is a compilation error because here we have already assigned n as 10, okay. So once we have assigned n as 10, we cannot further assign it as 5 because it is constant, okay. And so one might ask that what is the use of such a thing, like we wait. So if we are if we are using a variable, then we want it to change, right? So in the program, if somewhere we have used n, okay, let us say we have used n, so why do we need to use this variable n? We can just, in place of n, we can write 10 or something, okay, we can just directly write the value. Why do we need a variable? So the reason for this is that uh, there are several reasons. Okay, so one thing is that if we just write 10 in the program, then it is a bit difficult to understand that what does the 10 mean. Okay, usually when we write programs or we do something, it is based on some algorithm, right? Or it might be based on some mathematical formula or something like that. So we might have something like n plus m, okay, something like this. So this might be our mathematical formula. So instead of writing this, if we write 10 plus 20, then later on when somebody else is reading the code, it is difficult for them to understand that what is this. uh, so instead we use this letters, basically we use the letters. And the other thing is that uh, wait, okay, so now the other thing is that we are using the letters, okay. uh, the thing is that what if the value of this n changes? Okay, suppose we have used n plus n, then we have used n plus 2, then we have used 3 into n, okay, we have used several formulas that depend on n. Now what what will happen if the value of this constant changes? If we had just used the constant, then we would have to go all over the code and change everything. Okay, like I have a like good example. It came to my mind. So suppose we are designing some spacecraft or some lander, okay, which will operate on uh, a different planet. Now we know that the spacecraft has to be tested on Earth, okay. So the spacecraft has to be tested on Earth, and let us say that the spacecraft is being designed for Mars, okay. So then here the value of g is different, okay, and here the value of g is different. So in the program it is always better to, like, let us say we are using a formula as weight equal to mass into g, okay. Now instead of g we could have written m into 9.81, okay. This would also work, but it will work on Earth. Now if we, when the spacecraft is finally sent, okay, the final program, that the value of g has to be changed. Now if we had simply use 9.81 instead of g, then everywhere in the program we would have to change it, which would cause errors, okay. Like we would inevitably forget to change somewhere, or some other problem might happen. Wait a minute. Some people have joined actually. So it is better to use this. Now one rule of constant variables is that all constant variables, what is happening? Wait. Okay, one rule of constant variables is that the constant variables have to be initialized when they are uh, declared, okay. So we cannot just write const int n, we have to supply its initial value also, okay. Now why is this done? Because actually, because when the compiler it compiles the code, it substitutes the value of the constant variables everywhere, okay. So during compilation what happens is that this n variable, it does not exist, the value is substituted everywhere. So that is how it works. So that is why you need the initial value when you're defining it, okay. You can also have you can add const to anything, okay, even user defined data types such as this one. So suppose I create a new data type called complex, okay. It will have a real part and an imaginary part. So I can write const complex also, okay. And later on if I try to reassign its value to something else, it will not work, okay, it will cause a compilation error. Now we come to const pointers, okay. Now this is a bit confusing topic. So I am assuming that people know what is a pointer. If not, I can explain it again. Okay, so basically a pointer is a variable which, like, the pointer is a variable which does not store a actual number or a value or something. It stores a location, okay. So a location to what? It stores a location to a memory, okay. Now we know that we have RAM in the computer, where it is a sequential memory, okay. So you can think of the RAM as this, okay. Suppose we have a 4 GB RAM, then this will be byte number 0, byte number 1, byte number 2, okay. So it will continue like that till it reaches 4 gigabytes of memory. Okay, so it is a sequential memory, and a pointer is a variable which points to a location in this DIM. Okay, so you can think of it as something like, um, when you share your location on WhatsApp or something, you can think of it like this. So another thing is that we can add the const keyword to pointers also. So now we can add that, but what does it mean? So there are two cases. Okay, it can mean two things. It can mean that the first case is pointed to a constant data where the pointee cannot be changed. So the first case means that let me change this. The first case means that this value cannot be changed. The one I have marked in blue. So this is the blue one. Okay, blue case. So this blue part is constant. Okay, but the this pointer itself is variable. So this is the first meaning. And now the second meaning will be that the pointer is constant, which means the location cannot be changed. Okay, so this first one, okay, where I have marked this in blue, what does it mean? It means that the location can be changed, okay, but whatever it is pointing to, that cannot be changed. Okay, so this means that the location can be changed. I can assign this second location to the same pointer, okay, but whatever location I assign to that location, I cannot modify. This is what it means. Okay, now in the second case, the pointer is constant but the pointee can be varied. Okay, so in this case it means that this is constant. Okay, so the pointer is constant. It means that this location is fixed. Okay, this location is fixed, but the value can be changed. Okay, the value at this location, it can be changed. So these are the two ways the we can use const with pointers. Okay, and of course we can do both. Okay, we can do both if we want to. So this is a handy rule to decide on the meaning of the const. Okay, so to decide on the constness, draw a mental line through the star. Now you know that, like if you, like in C, if you have used pointers, you know that whenever there is a pointer, there is a star involved. Okay,
Okay.
so to decide on the constant, we have to draw a mental line through the star. Okay, so now in the first case, we don't have the const keyword only. There is no const keyword, so nothing is constant. Everything can be varied. In the second case, I will draw a line through the star. Okay, and if the const is on the left of the line, then it means that it is the first case. Okay, non-const pointer to const pointee. Okay, let me. So this is the first case, and similarly this is also the first case. Okay, now over here, so this one I have covered, this one also I have covered. Now over here I will again draw a line through the star, and the const word is after the star. Okay, so it means that the uh, pointed, I mean it means that the pointer cannot be changed, so the location cannot be changed. It is the second case. And in the last case, uh, both are const. There are two consts in the data type. It means that both the location and the value, it cannot be changed. Okay, Now I will move on to the volatile keyword. Okay, this keyword is rarely used by any high level programmer. Okay, if you are working on some desktop C++ application, you will most probably not have to use this keyword. This keyword is used for those who are programming at low level, okay, hardware level, embedded programmers or something. So if you have used Arduino or Raspberry Pi, okay, if you have used such hardware boards, then in those boards you will have to use the volatile keyword sometimes. Okay, so the volatile keyword, it instructs the compiler not optimize, reorder or remove a variable. Okay, so ordinarily what happens is that the compiler tries to optimize your code. Okay, so if you have written some useless things, okay, let us say that you have declared a variable in your program, but you have not used the variable anywhere. Okay, understood? Or let us say that you have written some line like this: a equal to 2, a equal to 3. Okay, so then the first line is useless because after the equal to 2 statement you have the equal to 3, so the this statement need not be there because it does not change anything. Suppose I have a program like this, okay, a equal to 2, a equal to 3, and then print it. So then the first statement is not required, right? If I just have a equal to 3, I will get the same output. So the first line can be removed. Okay, so when you compile a program with optimizations enabled, okay, the compiler searches for these kinds of cases, tries to uh, and it tries to optimize these cases either by removing or by rearranging. Okay, something it can do. So volatile keyword instructs the compiler not to do such a thing. Okay, not to not to remove a statement or do any optimization. Now why would somebody want that? Okay, why would the programmer want that the compiler not optimize their code? It is because the variable may be changed by some external means that is outside the control of the program. Okay, so this is a bit difficult to understand. It means that we are telling the compiler that the variable may get changed outside the programmer. Okay, some hardware thing or some OS thing might change the variable. Okay, so that is why you like the compiler cannot be sure that the variable will remain constant or unchanged or something, so it cannot optimize it. So one example let me give you. Suppose I have a pointer. Suppose I have a RAM. Suppose I have a RAM and I have a pointer which points to this specific location. Okay, now we are assuming that this is some low level hardware board. Okay, uh, quite low, like this is some hardware project. Okay, not some software project. So the thing is that this memory location, it is now connected to a switch, a hardware switch. Okay, and if a user presses the switch, the value at this location might change. Okay, because it is connected by hardware, or maybe this location is connected to a sensor. Let us say some light sensor or um, some light sensor or some other kind of sensor. So whenever somebody switches on the light, the value at this location will change. Okay, so and now we have written a program where we are reading the value at this RAM location. Okay, so what can happen is that the value at this location, it will change beyond the control of the program, right? whatever the program is doing, it doesn't matter, because when some human comes and presses the switch, the value will change. So it is better not to optimize such variables because it is outside the scope of the program. Okay, now I will go over some examples. So suppose I have this function, okay, where I have the I variable, okay, and I've written while I not equal to 100. So you will see that since I is not being updated, okay, I is not being changed at all. So what will happen is that this will become an infinite loop. Okay, so if something uh, if somebody calls this function, it will uh, not exit this function. It will stay in this function forever. So what the compiler can do is the compiler can optimize it like this. Okay, so over here you can see that the compiler has removed the condition and replaced it with 1, because it will give the same behavior. Okay, once the program enters the function, it will not leave it. The same behavior will happen. So this will what will happen normally. But if we use this volatile keyword, then the compiler does not optimize. So this is the case of volatile. Okay, now I'm proceeding to the next topic. Next we have the inline keyword. So the inline keyword, it is a instruction to the compiler to embed, okay, or inline a small function at its site of call. This way the overhead of passing parameters between the caller and callee is avoided. Okay, now when you know when we have to call a function, okay, if you have studied operating system, you will know that how a function call is done. Okay, we have a program, okay, and the program is executed line by line. Okay, the program is executed line by line, but when a function call is there, then what happens is that the, the arguments, they are pushed to the stack. Okay, the arguments of the function, they have to be pushed to the stack. Okay, then it has to jump to the new location. It has to jump to the new location, it will execute the function. Okay, then it will return from the function, and then it this arguments will again have to be popped back from the stack. So this is how it works. Okay, so there is some overhead in calling functions. So what we can do is that if our function is very simple, something like x square, okay, or some x plus 2, something like that, if our function is quite simple, let's say 2 3 lines or 3 4 lines, then we can inline it. Okay, we can put the inline keyword, and the compiler will try to uh, replace this with this. So this will be replaced here. Okay, now the one thing is that this inline thing, it is a recommendation to the compiler. It is not a, like, it will not be enforced. The compiler will still see that whether it is possible to embed the function over there or not. If it is possible, then it will embed it, or else it will not embed. The other thing is that previously in C there is something called macro, okay, where we can do something like hash define square x, and then we can write it as x into x, something like this we can write. Okay, so what is the difference between this macro and the inline function? The major difference is that the okay, so the major difference is that the inline function, it follows all the semantics and the type checks of the function call. Okay, so you can see that the argument, it has a type int, and the return value, it also has a type int. So all of these will be checked when the function is called. In case of macro, it will not be checked. So inline functions and macros, they do the same thing, but for inline functions some more checks are performed. Next, we have references. Okay, so a reference is a alias or a synonym for an existing variable. Okay, conceptually it is very similar to pointers. Okay, but pointers pointers are error prone. Like when people use pointers, especially beginner programmers. Okay, when they use pointers, they it is very easy for them to make mistakes. Okay, not only beginner programmers. Okay, or even advanced programmers, when we are using pointers, there is a high chance of making mistakes. So in C++, the concept of references was added. So conceptually, references and pointers are same or similar. Okay, but references, they are more safer to use. So how does this work? Suppose we have a normal variable such as int I equal to 15. We can define a reference to I as j. So using this syntax. Okay, the syntax is int ampersand j. So int ampersand this thing, it says that this is the reference. So int ampersand j equal to I, it says that j is a reference to I. Next, suppose we have something like int a equal to 10 and then ampersand b equal to a. It means that b is a reference of a. So reference also means that a and b have the same memory location. So again, let me draw a RAM. So the variable a and the variable b, they point to the same location. So this is what the this line means. A and b, it point to the same location. So you can see the similarities between this and pointers. If you also print their address, then the address will be same. Excuse me, 1 minute. Some people are joining. Okay. Next, we have call and return by reference. Okay, call by reference and call by and return by reference. Okay, these are two things. Now, I think all of you have. I think all of you know the first one, which is call by reference. Almost every, like when we learn programming languages, so we usually encounter these two things. Okay, call by value and call by reference. So the call by reference is similar to what we have learnt in other languages. It means that if we put a reference in the argument, okay, so you can see again the syntax of the reference, int ampersand. So if we put the reference, then it is kind of like passing a pointer of the variable. Okay, again, like let me say that pointers and references, they are different, but conceptually they are similar. So it means that we are passing the location to the program. Like not, if we don't use the reference or if we don't use pointer, then what happens is that the variable is copied. Okay, now this is not a problem for small variables such as int, float, double. Okay, but if our variable is large, okay, if or the data structure is large, then copying it might take time and it might slow down the program. So in those cases we use call by reference. Now one thing in C++ is that we can also return by reference. Okay, so our return type can be a reference and we can do that also. Like here I've written a very uh, useless function, okay, called identity. The function takes x and it returns x only. Okay, now because x is a reference, so this works. Okay, so that is also possible. The return by reference works in the same way. It is like passing a pointer. Okay, but one thing you have to be careful, which is that you must not return a reference to a local variable. Suppose we have a function and here we have defined some local variable. Do not return a reference to x. Okay, so now y is a reference of x. Okay, now you can return y. Okay, but do not do this, because once the function is done, okay, once we have exited from the function, then this local variable, it does not exist. Okay, so let us say the function is executing like this. Okay, now over here we return it, so it gets out of the function. Okay, but once it is out of the function, this x variable, it does not exist, so the y will point to some invalid location. Okay, so that is why do not return a local variable by reference.
Sir,
Yes,
sir, can you explain this again?
this one, the
Yes, sir. Return by reference.
okay. Okay, so what I mean is that uh, like the call by reference, you know that we write the function and then we write in the argument, we write int ampersand, which says that this is a call by reference argument. Okay, and then we can call the function like this. Okay, in our code we write identity, and suppose I write here n. Okay, then we know that what happens is that uh, a reference of n is passed into the function. Okay, the actual value of n is not copied, only a reference of n is passed. Now the thing is that C++ allows us to do the same thing while returning. Okay, while returning, if we write, suppose suppose that this is the actual function call, then while returning also we can return a reference. It will mean that this m variable, it will store a reference to some variable, instead of a actual value, it will store a reference to some value. So in this case what will happen is that uh, we have the variable n. Okay, now when we are calling the identity function, this a reference of n will be passed into the function, and the function will also return the same reference. So m and n will basically become the same thing, they will point to the same location. So this is an option which C++ allows us. But one thing you have to take care is that you should not return a local variable by reference. So what I mean is this: in the function, okay, like this is a this in this function there are no local variables, but in our function, suppose we have defined some local variables like int abc, something like that, okay, then you should not return these local variables by reference. Okay, this you should not do. The reason being that when the function is over, okay, when the function call is done, okay, then all these local variables they are deleted. Okay, so that is why it might give some garbage value in that case. So that is why, like, do not return local variables by reference.
Okay, sir.
Okay, now the next topic is very simple. Okay, so C++ allows us to pass default function parameters such as this. Okay, so this is a function, as you know, and in the argument list we can write int a equal to 10. It means that this function can be called without any parameter. So without any parameter also I can call it like this. So what will happen is that the default value, which is 10, it will be substituted. So this will return 10. Okay. Next we have function overloading. So it means that we can use the same name for functions with different function signatures. Okay, so that is called function overloading. So we use the same name such as add. Okay, so we use the same name but different signatures like int and double. Okay, uh, different signatures means that the function body might also be different. Okay, but the name is same. And so the correct function will be, so like the thing is that when we then use the function, okay, suppose in some program we write y equal to add a comma b, something like this we write. So then how will the compiler identify which function to call? So the correct function will be resolved at compile time. Okay, now remember that this is compile time. Okay, resolution. There is also something which is runtime resolution. Okay, but this function overloading, this is compile time. So the correct function will be resolved at compile time by either the number of parameters or the type of parameters. So basically, if your a and b they are integers, then the first one will be called. But if your a and b they are double, then the second one will be called. Okay. Now let us say you give one integer and one double, then it will show a compiler error, because there is no option to do that. Either both have to be integer or both have to be double. This is function overloading. Similarly, what we can do is we can overload operators also. Now operators are examples like plus, minus, into, or star, or you can have operators such as streaming operators like this. Okay, so you can also overload these operators. Overloading the operators means that you can change what the operators mean. Okay, so we can define or change the meaning of operators like this for both built-in and custom data types. And this is mainly used to write operations between custom data types in short form. For example, like a very simple example that all of you have used, okay, which is string concatenation. Okay, so suppose we have two strings, hello and world. Okay, now in most languages if we write plus between them, then they are concatenated. Now if you think about it, it does not make much sense, because plus is a mathematical operation. Okay, plus is a mathematical operation, so how can you do mathematical operations between two strings? Okay, but what we can do is we can define or we can change the meaning of the plus operator for custom data types such as string. So we can say that, like, we want plus to mean this in the context of strings. Then the advantage is that we can write things in short form. So then we can simply write this to concatenate them. Otherwise, for example, if this was not allowed, then we might have to use strcat to concatenate both the strings, so which takes a lot more characters and it is not very readable also. Another very good example is matrix mathematics or matrix algebra or linear algebra, okay, where you might have a matrix A and a matrix B. Now if you write plus between them, then ordinarily there won't be any meaning, okay, so there will be a compiler error. But you can define the meaning. You can say that if there is a plus between two matrices, then we want to add each of the elements, so then it will help us write this addition in short form. So that is the main use of operator overloading. For example, I've defined a data type called vector. So a 3D vector which has x, y, z. Okay, and then what I'm doing is I'm overloading the plus operator. Okay, now you know that the plus operator is a binary operator. It takes two arguments. So I'm supplying the two arguments, and I'm returning another vector which is the sum of all the components of each of the vectors. So this is how I overloaded the plus operator. Okay, now after doing this, I can simply use the uh, plus operator normally as we do in mathematics. So if I have defined a vector a and b like this, I can simply write c equal to a plus b, and all each of the components will be added. Like it will work as it is supposed, as it works in mathematics. Normally this will give a compilation error, but since we have overloaded the operator, it knows what is the meaning and what to do. So wait a minute. Okay, now the next one is dynamic memory management. So as you know that, like uh, if you have read about operating systems, okay, then you will know that there are two kinds of memories. One is the stack memory and one is the heap memory. So the stack memory is memory reserved for the local variables of the program. So if you have a function, okay, the function might have lots of variables such as a b c d e f g h or x y z or mn. Okay, so what what is done is basically, since all of those variables are defined in the function body, the compiler can understand that, okay, to run this function I need this much memory. Okay, and then it can allocate that much memory in some space. Okay, like it is a fixed size memory. For example, okay, for example, suppose this function, okay, okay, how much memory do we need to run this function? We can easily see, okay, here we have two variables a and b, and a and b both have three components. So 3 plus 3, 6 will be there, and then there is another vector c. It will also have three components. Okay, so to run this function we need enough space to store 9 numbers. So since this 9 numbers space is known from beforehand, the compiler can allocate a fixed size memory of size 9, and it can do the work of this function. So this is stack memory, because it is known from, like, the size is known from beforehand and the allocation can be done from beforehand. The other one is heap memory. Basically there is some programs in which we do not know how much size, what is the size requirement. Okay, so in this function, since it is very simple, we know. But what might happen is that, um, let us say we are working with a large file. Okay, so we don't know what is the size of the file, or what to, like, how much space to allocate for it. Okay. Or uh, yes, so one thing is that, or let us say we are working with a tree data structure and we do not know how much the tree will grow. Let us say we are implementing a tree data structure. Okay, we do not know how much deep or how much wide the tree will go, or we might have a linked list. Okay, we might have a linked list, so we do not know how, what is the size of the linked list, so we cannot say all of these from things from beforehand. So in that case the heap memory is used. So heap memory, it has to be allocated. So how does the heap memory work? So the program requests some amount of heap memory, and if it is allocated, then a pointer to that location is passed. Okay, pointer to that location is passed, and then the program can store some data over here. But the crucial thing is that after the memory has been used, or the job is done, you have to free this location. Okay, you have to tell the program or the compiler or the OS that I am not using this location anymore, you can use it for other programs also. In case of stack, this is automatically done because we know that once the function is over, none of the stack variables are used. Okay, so basically see, when this function will be called, okay, when this function will be called, this 9 number space will be allocated for this function, and this, it will stay there until this function is running. And when this function will exit, okay, it will exit over here. When this function will exit, we know that none of these variables are relevant anymore because the function has done its job. So these 9 numbers space, it will be freed for other programs, okay, automatically. But the same thing is does not happen with dynamic memory, because dynamic memory, it is difficult to say when it is being used and when it is not being used. So it is a job of the programmer to do that. Now here the problem is that many times if we are not careful, we forget to free the memory. Okay, and if the memory is not freed, then uh, the useless memory, it is occupied by the program, and it might cause the programs to crash. Okay, so in C we had malloc and free operators, and in C++ we have these operators. Okay, malloc and free is there, but we also have new and delete, and new square brackets, delete square brackets, and all that. Okay, now out of this I would suggest that use this new keyword. Okay, the syntax is this: new int, and then in brackets we can write the value of the memory location 5. So it will give us a pointer to this location, and we can print the value, and after our job is done we can delete the pointer. So delete p means it will free up the location. Now we come to the exercises. So this is the first exercise, which is what are the valid prototypes of the function add. So um, so please try on your own. I will solve it after 2 minutes. Okay, so here the answer is that A and E, they are valid prototypes. B, C, and D, they are not valid. Okay, and this is quite simple question because you can see that in B we have written int equal to 0. So obviously this is int equal to 0 and int equal to 0. So obviously this is not the correct syntax. In C also you can see that we have written double equal to 0, which is again not the correct syntax. This one is correct, okay, double d equal to 0 0.0, this is correct, but the double equal to 0, it is not correct. And in case of d, we have int equal to 0, and this double d equal to 0 0.0, this is fine, but int equal to 0, this is not correct. So the B, C, and D, they are incorrect prototypes, and A and E are correct. Now I will move on to the second question.
Sir, I think all should be incorrect.
Why?
Sir, because in lecture, sir explained that once we define one parameter as default, and after that every parameter is coming, that should also be default. From left to right, something like that. I don't remember exactly.
Let me check once. Okay, okay. Thank you. So actually it will be the opposite. Okay. Sorry. So A and E, they are invalid. Okay. B, C, D, they are valid prototype. Because in case of A, first we have the default parameter, but after that the second parameter is not default. Similarly, in case of E, we have the default parameter in the beginning, but N2 does not have a default parameter. In B, C, and D, the like in case of B, both have default values. C also has both default values, and D also has default values. Now the thing is that in B, C, and D, some of the variables names, they are omitted. For example, over here and here. In case of C also this is omitted. In case of D also this is omitted. So this is allowed in case of the prototype, like when we are writing the prototype. For example, we can write a prototype as int add int. Okay, so we can write a prototype like this. Okay, because this is a declaration of the function, but if we have to define the body of the function, then we have to give the variable names. Okay, like this. Okay, so please note the correction. So B, C, and D, they are valid, and A and E, they are not valid. This is the second question. Please try. I will discuss after 2 minutes. Okay. Okay, now let me answer it. So the question says that which pairs of prototypes are ambiguous and illegal. So basically it means that uh, when we when we are calling the function, okay, if we cannot identify that which exactly which function is going to get called, then we say that the prototypes, they are ambiguous or they are illegal. Okay, so when we are calling the function, if we cannot identify that exactly which function will get called, then that is ambiguous. Okay, so for example, so here we see that there are maximum three arguments, so we will analyze each case one by one. Okay, so suppose and like when checking for this, okay, when we are checking for this, uh, we do not check the return type. Okay, so these are the return types, but do not check these. Okay, because a function can be called without the return type also. So that is what we will check. So first we'll check first we'll call add without any arguments. Okay, uh, now there is one rule that uh, the compiler will try to use a minimum number of assumptions. Okay, so there is the rule. Okay, so suppose I have called add without any arguments, so the first one it will not be called because it accepts one argument and there is no default value. Okay, so the possible candidates are second, third, fourth, and fifth. Okay, all of them have three default, like two and three default arguments. So uh, any one of them can be called. Acha, one more thing is there, that if we call these three functions, okay, then the compiler has to make two assumptions. Okay, two default arguments will be used. But for the last case, three default arguments will be used. So the compiler will not prefer the last one. Okay, it will prefer one of these three. So one of these three will be called out of B, C, and D. So already you can see that without any arguments also this is ambiguous. Now let us call it with one argument. Let us say one. Okay. In this case, uh, for the first one, okay, it is a direct match. Okay, and the compiler has to make and the compiler has to make no assumptions if it matches it with the first one. Okay, so in this case this is not ambiguous. For the rest of the cases such as B, C, D, and E, this is still valid, but what will happen is that the compiler will have to make some assumptions. It will have to substitute the default values. So it will prefer not to do that. It will try to use the first prototype. Okay, so in case of one argument, this is not ambiguous. Now let us try two arguments such as this. Okay, so in this case for two arguments, you can see that B, C, and D, they are the candidates. Okay, the last one is also a candidate, but over there the compiler will have to assume that the third value is 0, which it will prefer not to do. So B, C, and D are candidates. Now over there also, if 1 and 2 they are integers, then B will be called definitely. Okay, but if 1 is an integer and 2 is a double, then there is a confusion between C and D. Okay, you cannot say that which one will be called. So again this is ambiguous. Okay, this two argument case is also ambiguous. Okay, because we cannot differentiate between C and D. And now let us try for three arguments, and for this of course there is only one function signature, so this is not ambiguous. So so as you can see that actually what I mean is that there are actually lots of pairs. Okay, this maybe this question could have been framed better. Okay, but there are lots of pairs which are ambiguous. So in case of the in case of the no argument case, suppose you have no arguments over here, then there are four four possible solutions. No, actually three possible solutions, B, C, and D. So here we have three C2 pairs, or um, three three C2 means three pairs. Okay, three pairs, and over here there is no ambiguity. And in this case, add 1 and 2, there is one pair. So total there are four ambiguous pairs. Okay, now I'm proceeding to the next question. So this is the next question. Please try on your own first, then I'll solve it. Yes, as some people have said in the comments, so actually it is a ambiguous situation, so there will be an error, okay, about ambiguous, like saying that it is a uh, ambiguous situation. Because see, when we have written add 10 comma 20, okay, it can either go to B or it can go to D. Okay, so there is a ambiguous situation here. The first two arguments are the same, and the last argument, okay, uh, first two arguments are the same, okay, and the last argument also there is a default value, so it is ambiguous. Okay, now I'll go to the next question. Okay, now we will solve the question. Okay, so this example actually highlights the difference between macros and inline functions. So the first case, which is double, this is a macro, whereas the second case, which is triple, this is a inline function, and there is a difference between these two. Okay, so the inline function, it works as you would expect a function to work. Okay, so there is no tricky thing with inline functions. So we have written here triple 10 plus 10. Now 10 plus 10 is 20, so 20 will go here, and 3 into 10, so 60 will be returned. Okay, so the second line will return 60. Now in the first line, okay, this hash define macro, it will be substituted. Okay, it will be exactly substituted like that. So this 10 plus 10, it will be substituted over here as it is. Okay, so you will have something like 2 into 10 plus 10. Okay, so as you can see, like what we meant, so this is what is this is equal to 30, right? But what we meant was, we meant double. So what we meant was this, but actually the answer turns out to be 30, because this is just normal, this is just substituted over here like this. Okay, no bracketing or order of operations they are followed or maintained. Okay, so the first line will print a 30, so the answer will be 30 comma 60. Okay, so this is why, like in C++ it is always, like in C there is no inline function, so people use macros. Okay, but in C++ it is always preferable to use inline functions and avoid macros whenever possible. Okay, so now I will go to the second, like next question. So this question is fill in the blanks, and that the output is 11 11 20 20. Okay, so as some people have said, so the blank has to be filled with reference. Okay, both called by reference and returned by reference. Okay, I'm writing it again over here. So okay, like this. So that is the answer, but how does this work? Okay, so how it works is this, that you can see this function. Let me write the function body also. So the function body is return plus plus I. Okay, so this is the function signature and this is the function body. So you can see what it does is it takes it accepts a reference to an integer, it increments the reference and it returns the reference back. Now as I said that the pointers and references, they're different things, but you can conceptually think in the same way, that we accept a pointer to something or a memory location of some place, and then we increment it and then we return the location back, something like that you can think. Okay, so now we come to the main function. So your x is equal to 10 and y is equal to 20. Okay, wait, better I will let me draw it in terms of the RAM. So again I will draw the RAM. Now the first line, x equal to 10, y equal to 20, it allocates two spaces for two variables. Okay, so now we have 10 here and we have 20 here, and this is x and this is y. Now when we write increment x, okay, now this passes a reference of x onto the into the function, and it is incremented, and then the reference is returned back. Okay, and the reference is assigned to z. So one thing you must remember is that the reference over here, it has not been changed. Basically the input is I, and then that same I is being returned only, so no new reference is being created. So what will happen is that z will also point to this same location. Okay, x and z, they will point to this same location. One thing will happen is that the value of 10 will change to 11 because we have incremented it. Okay, now when we print x and z, 11 and 11 will be printed because x and z, they both point to the same location, so 11 and 11 will be printed. Then we have this strange syntax, like normally, like we are not used to this syntax. uh, Increment x equal to y. Okay, this means that as increment x, what does it return? It returns a reference, right? It returns a reference. And which reference? So whatever the input reference we are giving, the same thing is basically returned. Okay, there is no new reference which is created. The whatever we are inputting, we are getting at the output. So basically it is a reference to x only. Increment x will return a reference to x only. Okay, and then we are assigning that reference to y. Now y, as you can know, is y, as you know, it is its value is 20, right? So uh, okay, so y is 20. So what will happen is that the this memory location will be updated with the new value. Okay, y, the y's value will be copied over here. Okay, because of this assignment operator. So then when we print x and z, we will get 20 and 20. So the output will be 11, 11, 20 and 20. So there is a question that What if we change plus plus I to I plus plus? So there will be no difference actually. Okay, because the return is okay. No, wait. There will not be any difference actually. Okay, so you are saying that I plus plus throws an error. So I plus plus might throw an error because um, it might throw error because the function has finished, right? Yeah, so the error is that non-const L value reference to type int cannot bind to a temporary of type int. Okay, let us see. So if we have this, okay, return I plus plus, okay, so we can break it down. Okay, then if we break it down, then it means that first the return I is executed, then we have I equal to I plus 1. So like the issue could be something like this, that when you are returning this I, okay, now remember over here that I is a reference. Okay, so when you, like, after you return the value of I, in a way, like, the function finishes, okay, the function ends. So the issue could be that I here, it basically does not exist. So how can you do it? Okay, that could be the error. I'm actually not.
Okay, sir.
Yes. Yes, of course, if you return by value, that error will not come. Okay, then I will proceed to the next question. So this is the next question. Please try on your own. How many questions are left? Okay, so um, I will conclude it in 10 minutes. So what is the output or the error? So in the first, so this is a difference between hash define and const. Okay, so when we use const, it works as it is supposed to. Okay, there is no, there are no tricks or anything, so it will work as it is supposed to. So so c2 is equal to 11, so you can substitute 11 over here and 11 over here. So 100 into 11 will be 1100 and 1100. Now this c1 will be just replaced with 10 plus 1. So n1 will become this, because this c1, it is a macro, it is not a constant or a variable or something, it is just a macro. So n1 will become 10 plus 1 into 100 into 11, and n2 will become 11 into 100 into 10 plus 1. So 1100 and wait a minute, yes, so n1 will be 1100 plus 10, so 1110, and n2 will be uh, 11,000 plus 1. Okay, so you are asking that why c2 replace as it is. So c2 is a constant, okay, it will behave like a normal variable only. So you will know that you know that c2 is basically 10 plus 1, it should be 11, so you can simply substitute 11 in place of c2. But with c1, it is not a constant, it is just a find replace kind of thing, it is a macro. You have to just find c1 and replace it with the text. Okay, so over here what we have is c1 appears over here two times, so we found the locations. Now we have to replace it with this right hand side. So here I have replaced those things in place of c1. Yeah, you can see that in place of c1 I have replaced 10 plus 1, like this. So that is how now you can see that it does not work as we have expected it to. We expected it to be 11 into 100 into 11, but that is not the case. So because of this plus sign, so we finally get these values of n1 and n2. Okay, so then I will proceed to the next question. Okay, please try this on your own. Okay, there is a mistake in this question. This should be A. Okay. Okay, guys. So yeah, yes. So this will be an error. Okay. Even like before the correction or after the correction also, this will be an error. So the reason being that um, when we create a reference, we create a reference of some variable. Okay, we cannot create a reference of some temporary value or some expression. Okay, so yeah, a plus 1, this is an expression, or if you have something like 5 plus 3, this is an expression. You cannot create a reference to this. A reference has to be to a variable. Okay, something like this is fine, but this is not fine. So this line will cause a error. Okay, so then I'm proceeding to the next question. Please try this. Okay, so this question, so let me now solve it. So I is 10, and then I created a reference to I. So uh, we have 10 here, which is I, and then R is a reference to I. Okay, and so now then we come to this confusing line. So in this line of this increment operator will have the higher priority. So increment operator will have the higher priority. So first will the plus plus R will be done. So this will be incremented from 10 to 11. this will become 11. And now basically what we have is like now if we ignore the plus plus operator, then we have something like this. Okay, so we will now execute it from right to left. Okay, like this. Okay, so first we'll do this. Okay, I plus equal to r. Now r is also basically I only, so it will be I plus equal to I, which is basically like this, I equal to I plus I. So I will be doubled, so it will be go from 11 to 22. So first if I track the history of I, first it was 10, then it became 11, now it will be 22. Okay, so this is done. Now we can further simplify this original line. It will be r plus equal to I. Okay, and now r is also basically I only, so it will be again this, which we know that it doubles the value, so it will go from 22 to 44. So then when we print it, we will get 244. Again, because r and I, they are the same thing, so we will get 244. So the answer is 44, 44. Okay, so there is a good question that in the chat that hmm, there is a good question in the chat that if we do C out I and then R plus plus, then we'll get 45 and 44. Why? Because the first the R plus plus will be uh, calculated, and then let me write it here. So the question is that if we do C out, then the output is 45, 44. So why is that the case? Now till here I am assuming that I equal to R equal to 44. Okay, so this C out, so first the R plus plus will happen. Okay, so the expression of R will be used first, and then it will be incremented to 45. Okay, and then this will execute from right to left. Okay, why? Because see, R will be streamed into this, then this will be streamed into this, then this will be streamed into C out. Okay, okay, no, wait, sorry. Sorry. So I, so see, this streaming operator, it will take this cout object and I, and it will return another like kind of stream cout object. Okay, so first this will go here, then this will go, then this will go. Okay, uh, but since r has the highest r plus plus has higher priority, because you know that the increment operators, they have higher priority. So first this r plus plus will be executed. So here the value of 44 will be used because this is post increment. Okay, but since I and R, they point to the same location, so this one will become 45, and then they will be streamed to C out, so you will get 45 and 44. Okay, so that's all for today's class. Okay, so thanks for joining. Okay, I'm concluding the session. So the sessions are weekly, so next Tuesday 6 to 8.
Hello, good evening, sir. Hello. Uh, Arya, sir, am I audible?